The opposite is also possible, and let's illustrate it by another example. So I have two coins, and they're all both of them are badly biased. One coin is much biased in favor of heads. The other coin is much biased in favor of tails. So with probabilities being 90%. Let's consider independent flips of coin A. This is the relevant model. This is a model of two independent flips of the first coin. There's going to be two flips, and each one has probability 0.9 of being heads. So that's a model that describes coin A. You can think of this as a conditional model. It's the model of the coin flips conditioned on the fact that I have chosen coin A. Alternatively, we could be dealing with coin B in a conditional world where we chose coin B and flip it twice. This is the relevant model. The probability of two heads, for example, is the probability of heads the first time, heads the second time, and each one is 0.1. Now I'm building this into a bigger experiment in which I first start by choosing one of the two coins at random. So I have these two coins, I blindly pick one of them, and then I start flipping them. So the question now is, are the coin flips or the coin tosses, are they independent of each other? If we just stay inside this submodel here, are the coin flips independent? They are independent because the probability of heads in the second toss is the same, 0.9, no matter what happened in the first toss. So the conditional probabilities of what happens in the second toss are not affected by the outcome of the first toss. So the second toss and the first toss are independent. So here we're just dealing with plain independent coin flips. Similarly, the coin flips within this submodel, they're also independent. Now the question is, if we look at the big model as just one probability model, instead of looking at the conditional submodels, are the coin flips independent of each other? Does the outcome of a few coin flips give you information about subsequent coin flips? Well, if I observe 10 heads in a row, so instead of two coin flips, now let's think of doing more of them so that tree gets expanded. So let's start with this. I don't know which coin it is. What's the probability that the 11th coin toss is going to be heads? There's complete symmetry here, so the answer could not be anything other than 1/2. Let's justify it. Why is it 1/2? Well, the probability that the 11th toss is heads, how can that outcome happen? It can happen in two ways. You can choose coin A, which happens with probability 1/2, and having chosen coin A, there's probability 0.9 that it results in that you get heads in the 11th toss. Or you can choose coin B, and if it's coin B, when you flip it, there's probability 0.1 that you have heads. So the final answer is 1/2. If I don't, so each one of the coins is biased, but they're biased in different ways. If I don't know which coin it is, their two biases kind of cancel out, and the probability of obtaining heads is just in the middle. It's 1/2. Now, if someone tells you that the first 10 tosses were heads, is that going to change your beliefs about the 11th toss? Here's how a reasonable person would think about. If it's coin B, the probability of obtaining 10 heads in a row is negligible. It's going to be 0.1 to the 10th. If it's coin A, the probability of 10 heads in a row is a more reasonable number. It's 0.9 to the 10th. So this event is a lot more likely to occur with coin A rather than coin B.